Hello everyone, welcome back to the online classes by Konnur institutions. In last class we were discussing about the solubility and solubility of a solid in liquid. In last class we were discussing solubility definition and saturated solution and unsaturated solution and factors affecting the solubility of solid in a liquid. So I will remind you in 5 minutes what we taught in last class. Solubility means the maximum amount of a solute which dissolves in a particular amount of a solvent at a specified temperature or specific temperature. That is known as a solubility. Saturated solution means the solution in which no more solute can be dissolved. That solution is known as a saturated solutions we will call. And one more is unsaturated solution. That is unsaturated solution means the solution in which more solute can be dissolved. That type of solutions are known as the unsaturated solution. And one more is dissolution process or dissolution means when we add a solid solute to the solvent, solute will be dissolved in a solvent. It means concentration of the solute in the solvent will be increases. That process is known as a dissolution. And also we are discussing crystallization. Crystallization means when we add a solute to the solvent or a saturated solution to the solute will not be dissolved in a solvent, so that will settle down at the bottom of the container as a crystals. It means those solute particles will collide each other and get precipitated as a crystals. That process is known as a crystallization. And also we were discussing about the solubility of a solid in liquid. So one is the factors which affect the solubility of a solid in liquid is the nature of solute and the solvent. So it depends on nature of solute and the solvent. Polar solutes can be dissolved in a polar solvents and non-polar solutes can be dissolved in a non-polar solvents. And effect of temperature we were discussing. So if the dissolution process is exothermic reaction, so according to the Le-Chatelier principle, the equilibrium move towards the backward side or endothermic side. It means the solubility of a solid in liquid will be decreases with increase in temperature. And if dissolution process is endothermic reaction, in such cases according to the Le-Chatelier principle, the equilibrium move towards the exothermic side or forward direction. It means solubility of a solid in liquid increases with increase in temperature if the dissolution is endothermic. And the effect of pressure we were discussing, that pressure has no effect on the solubility of a solid in liquid because solids are highly incompressible. So this much we discussed in the last class. In today's class we will discuss about the solubility of a gas in liquid, very important. So now we discuss that solubility of gas in liquid. So now liquid is act as a solvent, gas is act as a solute here. What are the factors which affect the solubility of a gas in liquid? Same, that is the nature of a gas, that is a solute and the solvent, and also effect of temperature we will discuss, and very important, the effect of pressure we will discuss. So that first one, for example, you can take the polar gases like HCl you can take, and you can take NH3, you can take SO2. These are polar gases. It means this is having a charge. Already told why the charge separation will occur, because of the difference in the electronegativity between the two atoms. These polar gases will having a more solubility in a polar liquid like H2O. These gases having a more solubility in a H2O. So non-polar gases you can take. Example, you can take oxygen. When oxygen dissolved in a H2O, that is a polar solvent, that is a liquid, and is non-polar gas, oxygen. When oxygen dissolved in H2O, this oxygen having a less solubility compared to the polar gases. And this oxygen, if you dissolved in a like a benzene you can take solvent, this is having a different solubility in a benzene and oxygen having a different solubility in H2O. It means different same gas having a different solubility in a different solvents, and we can take the N2 also, nitrogen gas, having a, if you dissolve in water, that is having a different solubility, and nitrogen also having a different solubility. These two gases, if you dissolve in water, these does not having the same solubility in a same solvent. So it means different gases having a different solubility in a same solvent, and same gases having a different solubility in a different liquids. It means polar gases having a more solubility in a polar solvents like water. These highly soluble gases having a less soluble in organic solvents like benzene, CS2, CCl4. That point you can remember. Polar having a more solubility, and non-polar having a less solubility, or polar non-polar having a less solubility. So which factor will affect the solubility of a gas in liquid? So that is the nature of gas, that is solute, and solvent also. So HCl, NH3 having more soluble in H2O. And next factors affecting which affect the solubility of gas in liquid is effect of temperature. So very simple it is. When we increase the temperature, the soluble gases present in the solution will come out of the solution. So if we heat that one, the soluble gases will come out of the solution. It means gases, those dissolved in solution will come out of the solution, means solubility will be decreases with increase in temperature. Solubility is inversely proportional to temperature. Very important. So now how we can explain this one on the basis of Leach-Clear principle. If the dissolution of the gas in a liquid is exothermic, dissolution of a gas in liquid is exothermic. It means delta H should be what? Negative. So you can take the solute as a gas. Gas dissolved in a solvent will form the solution. So this is in dynamic equilibrium. So when we increase the temperature according to the Leach-Clear principle, so if you change will occur or the stress will occur by changing the temperature or pressure, the equilibrium will be altered. The reaction get back to the equilibrium. So to nullify the effect of a change, so the reaction moves towards the forward direction or backward direction. So that is according to the Leach-Clear principle. We will explain this one. So now gas and solvent and the solution. This is in dynamic equilibrium. When we increase the temperature, the reaction favors backward direction. It means towards what? Endothermic side. Towards endothermic side. If it is towards endothermic side, means the solubility of gas in a liquid will be decreases. See here. So if the reaction moves towards the forward direction, means gas is dissolved in a solvent and solution will occur. It means dissolution process is increases forward direction. So if the solution is converted into or separated as a gas, means soluble gases come out of the solution. Backward direction means the solubility of gas in a liquid is decreases. So if the dissolution process of gas in a liquid is exothermic, according to the Le-Chatelier's principle, the increase in temperature, the reaction towards the backward direction, it means towards the endothermic side. So it means the solubility of a gas in a liquid is decreases with increase in temperature. Solubility is decreases with increase in temperature. These two are inversely proportional to each other. Solubility of gas it is. Solubility of gas is inversely proportional to temperature. This is the effect of temperature on the solubility of gas in liquid. Next factor which affecting the solubility of gas in liquid is effect of pressure. Very important. So this effect of pressure. Effect of pressure can be explained on the basis of Henry's law. Henry's law. Before going to the statement of Henry's law, so let us consider the closed system. If it is a closed system only, then dynamic equilibrium will be reached or equilibrium will be attained. So when we had taken water as a solvent, so this water starts evaporation. If it starts evaporation means vapor molecules are collected over the solution. Vapor molecules are collected over the solution. These vapor molecules will put a pressure on the solution. So that pressure created by these vapors is called as a partial vapor pressure or vapor pressure. Vapor pressure means the pressure created by this vapor. Hence it is called as a vapor pressure. If a single component we had taken, that is a water, so that pressure is called as a partial vapor pressure we will call. This is also called as a partial vapor pressure. So when the evaporation will occur, the vapor molecules are collected over the solution. If here the evaporation and the condensation process are in equilibrium state. So when by increasing the pressure, by compressing the gas to a smaller value. So here we are having this much value. When we increase the pressure, volume of the container or the solution is decreases this much value. If you decrease the volume of this by increasing the pressure, the number of molecules or the gaseous or the vapor molecules per unit volume will be increases. Example we will take here. Example you can consider, this is the per unit value means we are having 2 vapor molecules. Is it or not? When we increase the pressure by decreasing the volume, the number of gaseous or the vapor molecules per unit volume will be increases. So here 2 vapor molecules are there. When we decrease the volume by increasing the pressure or by compressing the gas, the number of gaseous molecules per unit volume is increases. If the vapor molecules are increases means those vapor molecules collide one to each other, and also those vapor molecules will strike to the surface of the solution. When the vapor molecules strike to the surface of the solution, the gas gets dissolved in the liquid. So when the vapor molecules are strike to the surface of the solution, the gas start dissolving in a liquid. When the dissolution will be more when we increase the pressure. Very simple. More pressure, more solubility of a gas in a liquid will be there. If we want to soluble the gas in a liquid, we have to increase the pressure, or else the gas will not be dissolved in a particular amount of solvent more. So this is explained on the basis of Henry's law. So now this is called as vapor pressure or partial vapor pressure. This is the solubility. When we increase the pressure, the solubility of a gas in a liquid is increases. That solubility can be explained by the concentration term mole fraction. These are soluble gases will be there here. That can be explained on the basis of what it is? Mole fraction. So now we can define the Henry's law. So that is partial vapor pressure. Partial vapor pressure of the gas, where the partial vapor pressure will be there above the surface of the solution. The partial vapor pressure of the solution above the surface of the solution is directly proportional to the increase in pressure. Solubility of gas in a liquid is also increases. The partial vapor pressure of the solution present above the surface of the solution is directly proportional to the mole fraction of the gas in the solution. So solubility of gas in a liquid can be expressed in a concentration term like a mole fraction. Mole fraction of what it is? Mole fraction of gas. Partial vapor pressure of a gas present above the surface of the solution is directly proportional to the mole fraction of the gas in the solution. So now I will write the definition of the Henry's law. Partial vapor pressure gas present above the surface of solution is directly proportional to mole fraction of gas in solution. So that is mathematically written as P is directly proportional to Xg. Now it is, if you remove the directly proportional sign, constant will come, that is Kh into Xg. Kh into Xg. Here Kh is known as Henry's constant. And X is mole fraction of the gas. And P is partial vapor pressure. One more point you can remember here, Kh value is different for the different gases. If the increase in Kh value, if you increase the temperature, Kh value is also increases. So if you increase the temperature, increase in temperature, Kh value is also increases. These two are directly proportional to each other. And Kh value is inversely proportional to solubility. Very, very important. Kh value is inversely proportional to solubility. They asked many times one mass question regarding this one. If the more the Kh value, less the solubility of a gas in a liquid will be there, or less the Kh value, more the solubility of a gas in a liquid will be there. So they had given two gases and they had given a Kh values. Among those two gases, which one having a more solubility in a gas in a liquid? So they will ask. So they are already asked this type of a questions. You have to remember, more the Kh value, lesser will be the solubility of solid in a liquid. And we already know that solubility and temperature relation. That is, solubility is inversely proportional to temperature, or temperature is inversely proportional to solubility. So this is also very important, and so we can write that directly. So temperature is directly proportional to Kh value, increasing temperature, KH value is also increases, and KH value is inversely proportional to solubility. So this is the formula you have to remember. So this is the Henry's law. So hope you all understand the Henry's law. This is the, I will tell one more time regarding the definition of the statement of Henry's law. Partial vapor pressure of the gas. The meaning of partial vapor pressure is a pure component. One component vapor pressure or pressure, that is called as partial vapor pressure. Partial vapor pressure of the gas, where the gas will be created above the surface of the solution. That I am writing here. Partial vapor pressure of the gas present above the surface of the solution is directly proportional to the mole fraction of the gas in the solution. If the pressure is increases, solubility of a gas in a liquid is increases. So pressure is directly proportional to the water, mole fraction. That solubility of a gas in a liquid can be expressed in the form of concentration term like a mole fraction. So pressure is directly proportional to solubility here. More the pressure, more the solubility of a gas will be there in liquid. So this is the Henry's law. And now we'll discuss about the applications of the Henry's law and also limitations of Henry's law. Yes, as we already know that solubility is inversely proportional to temperature. One more point you can remember. Solubility is inversely proportional to temperature. More the temperature, lesser the solubility of a gas in a liquid will be there. Hence the aquatic species are more comfortable in cold water rather than hot water. In cold water, temperature will be low. In cold water, temperature will be low. Temperature will be low means the solubility of a gas in a liquid is more. Hence, those are more comfortable in cold water. In hot water, temperature will be more and solubility of a gas in a liquid is less. Hence, those are not comfortable in a hot water. So those are comfortable in a cold water. One more point you can remember regarding the solubility versus temperature. So now we will discuss about the applications of the Henry's law. Very important. So first application of the Henry's law is in the production of carbonated beverages or soft drinks. The soft drinks are the soda bottle. You can take the soda bottle. This is the soda bottle you can take. This soda bottle is sealed under high pressure. Sealed under high pressure. If you want to dissolve the carbon dioxide in this solvent, so we have to apply the high pressure. More the pressure, more the solubility of gas will be there. Under high pressure, this bottle is sealed. So when we open the lid, inside more pressure will be there, outside less pressure will be there. So when we open the lid, pressure will be decreases. Pressure is decreases means solubility should be what? Decreases. Solubility should be decreases. If the pressure is decreases means soluble gases like carbon dioxide coming out of the solution as a bubble. And when we open the lid, the fizz sound will also come. So when the pressure is outside the pressure and inside the pressure is equal, so that time the bubbles will stop. So this is in the production of carbonated beverages or soft drinks, Henry's law will apply to soluble the gas under the high pressure. So next application of the Henry's law, very important, is as we already know the scuba divers are sea divers we call. Scuba divers are sea divers. Consider this is the sea level. So scuba divers had taken a tank. That tank contains air, that is a mixture of oxygen and nitrogen. When the scuba diver enters into the sea or ocean, when he goes towards the deep, or the pressure will be increases. If the pressure is increases means according to the Henry's law, the solubility of a gas in the blood cell will be increases. It means more amount of air is soluble in the blood. If the more amount of gas will be soluble in the blood, means that air containing a mixture of oxygen and nitrogen, so that nitrogen will be soluble more in the blood cell. That is toxic to the body. This is the one problem he is getting. And one more thing is, when he goes deep into the sea, the pressure is increases. While coming back to towards the surface, so the pressure will be decreases. Pressure is decreases means, according to the Henry's law, the solubility of the gas in the blood cell is decreases, so that those gases will come out of the blood cells. Those cells, when come out of the blood cells, those will block the capillaries, so that symptoms in the medical word is called as a bends. That is pain we will call. So I will repeat this one. So when the scuba diver enter into the sea or ocean, when he go deep to the ocean, the pressure is increases. If the pressure is increases means solubility of gases in the blood cell will be increases. While coming towards the surface, the pressure will be decreases, and the soluble gases like oxygen and nitrogen will come out of the blood cell. While coming out of the blood cell, those will block the capillaries, so that symptoms will lead to the pain. That is, the medical word is termed as a bends. And when the climbers go towards the altitudes, so in altitudes the pressure will be low. When the climbers move towards the altitudes, pressure will be low, means according to the Henry's law, the solubility of a gas in a liquid will be decreases if the pressure is decreases. It means less oxygen is available for him. If low concentration of oxygen leads to the climber weak or sickness, and he will not think properly, that symptoms are medical word termed as a anoxia. It's very important, one mark question, anoxia and bends. These are the application. And the scuba diver tank containing a mixture of nitrogen and oxygen, and also it is diluted with the helium gas. So why the scuba diver tanker diluted with the helium gas means this is having a less solubility. Because of that reason, they are diluted with the helium gas. So this mixture will contain how much percentage, means that is a helium containing 11.7 percentage, and oxygen is 32.1 percentage, and nitrogen is 56.2 percentage. This is the mixture of that gases present in the tank. So one more point you can remember regarding this one is why the that air is diluted with the helium gas, means that is having a less solubility. This is the application of the Henry's law. In the next class we will discuss about the remaining part of the solution. Thank you.